We've talked a lot about the sum of the inside of a triangle, and now we're going to move on to other shapes with more sides. So to review, the sum of the measure of the interior of a triangle is 180 degrees. So if we were to label these as A, B, and C, we would get A plus B plus C equals 180. But now if we have a quadrilateral, which means it has 4 sides, the interior of that shape is 360 degrees. We get 360 because we could divide this quadrilateral up into 2 triangles. So this triangle is 180 and this triangle is 180. And when you add those two together, you get 360. So we can expand that and create a table here. So if we have our first polygon, a triangle has 3 sides, we know there is 1 triangle inside there, and the sum of its interior angles is 180. For a quadrilateral, there are 2 triangles, and the sum of the interior angles is 360. For a pentagon, we have 3 triangles, so the sum of the interior is 540. Hexagon, we have 4 triangles. 4 times 180 equals 720. And our last one here, 7 sides, we have 5 triangles. And that interior angles would add up to 900. So we could keep going to figure out all the different sides of these figures and figure out the interior angles, or we could find the pattern and recognize that there is an interior angle sum theorem, and we can use this equation, n minus 2 times 180, where n is our number of sides. This is going to give us the sum of the interior angle of a polygon. So let's test it out with a few examples. In this first example, we have a polygon with 5 sides. So to start off with, we're given 4 angle measures, and we want to figure out what this angle 1 is. So to do that, we need to know how many degrees total are inside of that polygon. So if we use our formula, we have n minus 2 times 180, where n is our number of sides. So we plug in 5 minus 2 times 180. I can plug that in my calculator and I get 540. So if I have 540 degrees inside my polygon, and I know that I already used 115 plus 98 plus 121 plus 90, add that up, I get 424. I've already used 424 degrees inside that polygon, and I have 540. That means I have 540 minus 424. I have 116 degrees left for angle 1. So that is my answer. In our examples, if It says that a polygon is regular. That means all of its angles are congruent. So that's an important fact to remember when you're doing some of these examples. So if we look at this example, it says find the measure of angle 1 for a regular octagon. That means all of my angles are congruent. So if I figure out the total number of degrees inside that polygon, I have 8 sides. I would take my formula 8 minus 2 times 180, which gives me 1,080 degrees total inside that whole shape. If each angle is the same, I can take that number 1,080 and divide it by 8 for each angle. And then I get 135. That means each one of my angles is 135 degrees. So that is our angle 1. Our next theorem says that the exterior angles of any polygon are going to add up to 360 degrees. So that means in this case we have angle 1 plus angle 2 plus angle 3 plus angle 4, angle 5 and angle 6 all equal 360 degrees. And it's also important to remember that if our polygon is regular, that means all the sides are the same, then our exterior angles are all going to be congruent as well. If our interior angles are all the same, our exterior angles are all the same. So for this example, it says find the measure of the numbered angle. Our given information in this example is we have our angle 1 is labeled there. We have 130 degrees and 105 degrees here. So if we know that all exterior angles add up to 360 degrees, we can add 130 plus 105. We get 135, and we can subtract that from 360. When we do that, we get 235. We get 125 degrees. So that means angle 1 is 125 degrees, since we know all three angles have to equal 360. All three exterior angles add up to 360. Okay, for our next example, this says that we have a regular pentagon. That means all the sides are the same, so all of our angles are the same. Find the measure of each exterior and interior angle. So first we want to know how many angles inside. And if we have 5 sides on our shape, we can plug in 5 to our interior angle formula. So we have 5 minus 2 times 180, and that gives us 540 degrees. We have 5 angles inside of our pentagon that are all the same. We want to take that 540 and divide it by 5. And we get 108 degrees. So this is our interior. Each interior angle is 108 degrees. For our exterior angles, we know there are 5 exterior angles as well. We have 1, 2, 3, 4, and 5. So the sum of all those are going to add up to 360. If we take that 360 divided by 5, we get 72. And this is each exterior angle. Okay, our last example says find out how many sides a polygon has with 3,240 degrees inside. So we know that our sum of interior angles is equal to our number of sides minus 2 times 180. If we know that sum is 3,240, we can solve our equation for n. First thing I'm going to do is I want to get rid of this 180 outside my parentheses. So if I'm multiplying, I'm going to divide both sides by 180. $3,240 divided by 180 gives me 18. I have n minus 2 left on this side. Add 2 to both sides. And my n is 20. So that means my polygon had 20 sides.